Section 1.2 is in this book, I think in part as kind of a review to make sure that we all know kind of what's going on here. So I already talked about general solutions and particular solutions and n-parameter families. So what I'm going to do is kind of do a couple of examples that are from this section, integrals as the general and particular solutions. But I'm going to kind of build in a couple of review items just to make sure that we know it here. Okay, so this is basically a Calc 1, Calc 2 review problem here. Example 19 says solve the IVP, which is y prime equals x sine x with y of 1 equals 0. So the Calc 1 aspect is to just realize that this just means that y is equal to the integral of x sine x dx, right? And we're good to go if we can do that integral. Now we get to the Calc 2 part, which is to say that I need to do that integral and I need a technique, and this is definitely a integration by parts, right? So let's just remember how to do this here. There are tons of different ways that people learn this, but here's kind of how I do it. Pick the u, pick the dv. So this is a x times sine problem here. So u is just going to be x, and dv is going to be sine x, and then here we go, du is 1 and v is negative cos. Watch out for that minus sign. This is like the most missed minus sign in mathematics there. Okay, so then my integral is going to be uv, so minus x cos x minus the integral of v du, so minus negative cos, so we'll just make that minus a plus there. And there we go. So then y is going to be negative x cos x plus the antiderivative of cosine is sine x. Once there are no longer any integrals, we add the plus c. So here is my one parameter family. That's the general solution of this particular differential equation, and all I have to do now is find c. So y of 0 is negative 0 times I don't care plus sine of 0 is 0 plus c, and all of that is going to be 1. So that means that c is 1. All right, cos 0 is 1, so I'll put that there. Got my c value, and so the particular solution is y equals negative x cos x plus sine x plus 1. All right. So a little integration by parts review there. Oh, problem 2. Problem 2 is y prime equals 4 over x squared minus 4 with y of 3 equals 6. So that means that y is the integral of 4 over x squared minus 4. All right, how do we do this here? Well, there is going to be a formula for this one, but I think the best way to go about this one is to do some integration by parts. Okay, this is definitely going to come up in this class, so let's just kind of take a chance to remember how this goes. The bottom factors as x minus 2, x plus 2. So it's going to be a over x minus 2 plus b over x plus 2. And so I have a times x plus 2 plus b times x minus 2 all over x minus 2 x plus 2. And all of that's equal to 4 over x squared minus 4. Okay, so now the denominators are equal. These two things are equal when their numerators are equal. So a times x plus 2 plus b times x minus 2 equals 4. Now, I don't know what methods you've learned in the past. Typically, a great way to do these is just to sort of compare the variables on both sides. So I have ax plus bx, which makes a plus bx's on one side and 0x's on the other. And then I have 2a plus 2a minus 2b equals 4 on the right-hand side. So you get a system when you sort of compare the x terms, and then over here, and the a and the number terms and 4 over there. That's all fine and good, and sometimes you sort of get stuck doing that, but why don't we do the easy way? And this easy way sort of makes me feel gross inside a little bit, because when you come back up here, if you take a fraction, say like x minus 2 times x plus 3 divided by x minus 2 times x plus 4, we say this is equal to x plus 3 over x plus 4. Plus 4. And that's all fine and good, except that's not always true. We actually have to sort of put a semicolon here. Oh yeah, by the way, x is not 2, right? Because those things cancel, and we can't plug in 2, because if we plug in 2, then I have 0 over 0 equals this thing over here. Now, what I mean by this way makes me feel gross over here is that you can plug in -2, and it will kill this thing and give you a stuff times b equals 4. And then you can plug in 2, and it will kill this thing, and it'll give you stuff times a equals 4. And this works, but it makes me feel gross because those are exactly the things you cannot plug in up here. So this method always just makes me a little apprehensive about stuff, but this does work. It is much easier, so you should do it, okay? So let's just do it here. When x is -2, I get -4b equals 4, and so b is -1. And then when I plug in +2, it gives me 4a equals 4, right? Because I'm just -2 is 0 times a. And then -2 minus 2 is -4. And then plugging in 2, I get 2 plus 2 is 4, and 2 minus 2 is 0. So then a is equal to 1. So that is significantly easier. So what I do is integrate. This is going to be, what was a 1 over x minus 2 plus -1 over x plus 2. And so this is an easy integral now. This is just ln absolute x minus 2 minus ln absolute x plus 2 plus c. And plug in some stuff, right? Just plug in y of 3 is ln of 1 was y of 3, right? Y of 3 equals 6, yeah. So that's ln of 1, that's 0, minus ln of 3 plus 2 is ln 5. And that whole thing equals 6. So then c is 6 plus ln 5. So we're done. So y is equal to ln x minus 2 minus ln x plus 2 plus ln 5 plus 6. Awesome. I am certain that you could condense that thing down into, or at least a single log plus 6. If you want to do that, great, go ahead. All right. Cool. So that was sort of a little bit of review there, along with content from section 1.2.